Hello, algebra students. Today we are going to be solving word problems. Oh, wait, I forgot to introduce myself. Mr. Lawrence here. Sorry about that. We are going to be solving word problems using factoring. It's pretty easy stuff. You gotta know how to read, and I know you do. Okay, we got some strange things going on here. Looks like we're doing okay. All right. So the first problem is the product. Hey, what does product mean again? Product means multiply. Okay, of three more than a number, what's that number? Let's call it x. How do I do three more than the number? Well, that would be x plus 3, right? So I'm going to take this x plus 3 and I'm going to multiply it by something. How do I know? Because it says the product. Okay, and 5 less than that number. Well, we're talking about the same number, x, and we need 5 less. Well, wouldn't that be x minus 5, right? So x minus 5. That's what I'm multiplying together. X plus 3 times x minus 5 as quantities is, that's a hard one, 9. All right, well, first thing I'm going to do is I'm going to FOIL. And I'm going to go x squared, and I'm going to get a 3x and a minus 5x is a negative 2x, and then a minus 15. And that's going to equal 9. Now, I don't know how to solve a quadratic equation that equals 9. I know how to solve them that equals 0. So I'm going to go ahead and make this equal 0. I'm going to subtract 9 from both sides. And when I do, I'm going to get x squared minus 2x minus 24, which will equal 0. Well, now I have a trinomial on my hands. And, of course, you can do the factors of 24 thing. I'm going to show you that, remember, I've mentioned in some other videos that if the lead coefficient is 1, right? I don't like to write the 1 there, but there it is. Let me get rid of it. If the lead coefficient is 1, I can just set this up like this. X and X, and I'm just going to think to myself, I need two factors of 24 that subtract to get negative 2. Well, it sounds like a 4 minus 6. So I'm going to get a plus 4 and a minus 6 equals 0. Now it looks like I'm going to have two answers. I know that this one here, I'm going to do x plus 4 equals 0, and x minus 6 is going to equal 0. And I know you're going to get x equals negative 4 or x equals positive 6. Now I should go back and test them and make sure they work. If I put negative 4 in for x, so I've got this x plus 3 times quantity of x minus 5. I need it to equal 9. Okay, if I put negative 4 in here, I'm going to get negative 4 plus 3, which is negative 1. And over here, I'm going to get negative 4 minus 5, which is negative 9. And negative 9 times negative 1 is positive 9. So it works. So negative 4 is good. Okay, and now if I put 6 in, I'm going to get 6 plus 3 times 6 minus 5. Well, that's going to be 9 times 1, which is 9. So they both appear to work. I'm going to go back and check the story, and it says the product of 3 more than a number and 5 less than that number is 9. Write and solve a quadratic equation to find the number or numbers. So my solution is correct. I wanted to check and make sure I wasn't restricted to like natural numbers or whole numbers or something like that. Integers are okay, so I've got negative 4 and positive 6. Piece of cake. All right, number 2, you have a 10-inch by 10-inch square. You cut a red rectangle off the top of the square. Right here, it's cutting off the square. It's x inches wide. I'm going to label that x inches wide. Okay, and then, well, maybe I shouldn't do that in blue. That might get hard to see. Let's pick a different color. Let's go with orange. All right, so that's x inches wide. And then you take a rectangle of the same width and tape it onto the new rectangle, right? And I'm supposed to find the area of this white plus this blue rectangle. Well, let's think about what we know here. This white plus this blue rectangle looks kind of, where are my shapes? Looks, whoa, I must be doing a square here. All right, so let me undo that. And let me do a rectangle. It's going to be that distance there, right? That measurement there. So let me move that over here and see if I know how long the side is. Well, someone's probably thinking it's 10, but it's not. Remember that from here to here is 10 inches. Okay, if I cut this part off, it's not 10 inches anymore. You know what it is? That's 10 minus x inches. So this side here is 10 minus x. Now, this distance from here to here was 10 inches, but we added the rectangle to it. So the base is 10 plus x inches. Well, now I need to find the area of the two together. Well, Jiminy Christmas, how hard can this be? I'm going to do 10 minus x as a quantity times 10 plus x, and that's a FOIL problem. And so I'm going to get 100 minus x squared, and that will be, what am I in, inches? Inches squared. And there you go. Piece of cake. All right, one more problem. Okay, this time we have a rectangular garden, and it's to have an area of 180 square feet. Well, first of all, I am going to draw my rectangular garden. And I know that the base times the height, or the length times the width, will have to be 180 square feet. Okay, that's all I know so far. There we go. So I'm going to write 180 feet squared. Okay, now the length is to be 3 feet more than the width. So what's the width? Well, I'm going to let the width equal W. The length has to be more than the width. How much more? 3 feet. So that'll be W plus 3. So I know that this is W, and I know that's W plus 3. And I need to write and solve an equation to determine the length and width. Well, how do I get area? I do W times W plus 3, and that will have to equal the area, which is 180. Going to distribute, get W squared plus 3W equals 180. Again, I don't know how to solve a quadratic that is equal to 180, so I'll subtract 180 from both sides. And this will give me W squared plus 3W minus 180. That'll equal 0. Okay, so I'm going to need two factors of 180 that are going to subtract to get 3W. Well, we have a W and a W. So let me think about this here. Factors of 180. Now they're going to be close together, so I'm not going to waste my time with things that are, right next to each other. I might jump to 10 and 18. All right, now 12, I think is going to go in. And you know what? I'm thinking 12 and 15. Let me see here. 180. If I break it up into 10, 18, well, let me do this somewhere else. Here, 180. And I know for a fact that 10 times 18 is 180. And I know that 10 is 5 times 2. And I know 18 can be 6 times 3, right? So 5 times 2, if 10 times 18 is 180, then so is 5 times 2 times 6 times 3, right? And if you heard me say 12, isn't there a 12 hiding right here? Doesn't that become 12? And isn't this 15? So therefore 12 times 15. 12 and 15 are factors of 180. And I need them to subtract to get positive 3. So subtract to get positive 3. So that would be 15 minus 12. So here we go. I've got it factored 15 plus 15 and then minus 12, and that'll equal 0. Now, you might be thinking there's two answers. You are not thinking clearly. You must have bumped your head on your algebra book, because if I solve this, I get W equals negative 15, and this one will equal 12. I'll tell you what, some of you probably like to argue, Gotham, and I bet you that you cannot draw me a width that is negative 15 feet long. Can't do it. So this one we will throw away. It's a false answer. I know the width is going to be 12 feet, and then the length is 3 more than that, so the length is 15 feet. Okay, but we can't have a distance that's negative. Negative distances only indicate direction. It's not possible for you to walk negative 2 miles. I mean, if it were, then you could go for a 5-mile run. Okay, you've run 5 miles, straight line, turn around, run home the same exact route, which would be minus 5 miles, and you've gone 0 miles. Now your net distance is 0 miles. Yeah, you're back where you started, but your body has run 10 miles. You're all sweaty and stinky and smelly. It's not like you run backwards and when you come home, your shirt is dry and you feel refreshed. Like, hey, let's go running again because I don't feel like I did anything. No, your net distance is uh, 0 miles, but you have run 10 miles, right? Okay, well, there's the answer. That's how you do it. We're going to get some practice in class. Mr. Lawrence signing off. Good night, everybody.